These are all the characteristics of the queuing model, and that we studied in the previous session. And these are the list of the formulae which we need to require for solving the problems, and you need to by heart these formula. So there are totally 14 formula. Out of 14 formula they will ask, and these all the formula belongs to the MM1 model only. That we have seen in the previous session. Also we have studied about this first problem in the previous session, and even the second also. Now we'll study about the third problem. An airline organization has one reservation clerk on duty in its local branch at any time. The clerk handles information regarding passenger reservation and flight timings. Assume that the number of customers arriving during any period is a Poisson ratio, Poisson distribution with an arrival rate of 8 per hour, and the reservation clerk can serve a customer in 6 minutes on an average. 6 minutes on an average. So by seeing this problem statement, we can understand that an airline organization has one reservation clerk. It means that it is a MM1 model. It is MM1 model. So there is only one service center. So it is the MM1 model. If there are two clerks or the n number of clerks, then we need to go for the MMK model. On duty, what is the arrival rate here? So 8 per hour. 8 per hour they are given, and the service rate they are given the 6 minutes on an average with an exponentially distributed with the service time. Next, what are the things you need to find? What is the probability that the system is busy? So already we have the formula. So those formula we can use it. What is the average time of a customer spends in the system? And next one, what is the average length of the queue? And what is the average number of customers in the system? These all four they ask, so we need to find all. Okay, first thing is, so what we supposed to find? So first, so we supposed to know that arrival rate, that is a lambda, as well as the mean service rate, that is mu. So once if you get these two values, then we can find all the answers. What is the arrival rate? Here they are given that 8 customers per hour, 8 customers per hour. And in the previous session also I told that you need to write the answers, that is per unit time, per unit time. So usually we'll consider that time with respect to the hour only. So in 1 hour, how many customers are arriving? 8. So the lambda value is 8 per hour. Lambda value is 8 per hour. Next one, what about the mu value that reservation clerk can serve? The reservation clerk can serve a customer in 6 minutes on an average. Okay, well, if he is taking the 6 minutes for one customer, 6 minutes for one customer, then how many customers he can serve in a 1 hour? How many? So for that, a mu equal to one customer served in a 6 minutes, one customer served in a 6 minutes, and for 60 minutes, how many customers he can serve? For 60 minutes, so it will be 10 customers in a 60 minutes. 10 customers in a 60 minutes. So how to calculate that? So 60 divided by 6. 60 divided by 6 is the 10. So that is mu is equal to 10 per hour. So mu equal to, therefore mu equal to 60 divided by 6, that equal to 10 per hour. Once if you know the value of lambda and mu, then we can find the value of, so whatever they ask. So what is the first one they ask? What is the probability that the system is busy? For the probability, the formula is rho equal to lambda divided by mu. We know the value of lambda and mu, then we can find that what is the probability. So for the first one, the formula is lambda equal to So rho equal to lambda divided by mu. So for the first one, lambda divided by mu, so that we can apply and we can find the value of that. The second one is, so what is the average time of a customer spends in the system? So for that average time in the system, so time is so W waiting time. So that equal to, for the system, it is the formula is 1 divided by mu minus of lambda. If you apply this formula, then again we can find the value of that average time of a customer spends in the system. The third one is average length of the queue. So for the average length of the queue, the formula is given. So already you know all the formulas, that is LQ equal to lambda square divided by mu into mu minus lambda. If you apply this one, so then you will get the answer for this. What is the average length of the queue? And the last one is average number of customers. What is the average number of customers in the system? For that, the formula they are given already. LS equal to LQ plus of rho or the lambda divided by mu. If you apply all these four formula, then we can find all the answers. Okay. In the next slide, I have written all the answers. If you want, you can note down. Sorry, as I already is given the PDF notes, so in that also it is there. First, we need to find the lambda and mu. So mean arrival rate is lambda equal to 8 customers per hour. So this is the lambda value. At the same time, mu value is 10 per hour. And the first answer, second, third, fourth. Okay, here, so units will be, so always, so unit will be a customers or the minutes. If it is a time, then you need to write in terms of minutes. If it is a number, then you need to write in terms of customers. Okay, next we'll move on to the one more problem. The fourth problem is self-service store employs one cashier at its counter. One cashier at its counter. One cashier in the sense, again it's a MM1 model. Again it is the MM1 model they are given. 9 customers arrive on an average every 5 minutes. Try to understand the statement clearly. 9 customers arrive average 5 minutes. So in every 5 minutes, the 9 customers will arrive. So okay, while finding the lambda value, we need to take care of that statement. While the cashier can serve 10 customers, in the 5 minutes. In the previous session also I have told that always the mu value should be greater than lambda. So I mean a service rate should be greater than the customer arrival rate. Okay, 10 customers in 5 minutes. Assuming a Poisson distribution for arrival rate and exponential distribution for the service rate. Find average number of customers. So again, so whatever the formulas we know, so from that only they will ask average number of customers in the queue, average number of first one is a system and next one is a queue. Average time a customer spends in the system and average time a customer waits before served. So all these formulas already we know that. You know, our intention is to find what is the value of lambda and mu. So that is the main intention. So if you make a small mistake while finding the lambda and mu, then your problem will be wrong. Okay, try to understand. 9 customers arrive on an average of every 5 minutes. 9 customers arrive on an average of every 5 minutes, in the sense totally in a 1 hour how many customers will be arriving. Lambda equal to 9 customers arrive in every 5 minutes. 9 customers in 5 minutes. Then how many customers in 60 minutes? This is a simple question. So in 5 minutes they are coming 9, and what about the how much in 60 minutes? So then how to calculate this one? 60 divided by 5 into 9. 60 divided by 5 into 9, that equal to 60, 12, 12 nines are 108. 108 divided by, sorry, per hour. And lambda rate is 108 per hour. Okay, mean at the same time, so what is the value of mu now? What is the value of mu? So that is the service rate. The 10 customers in a 5 minutes. So the cashier can serve 10 customers in a 5 minutes, in the sense, so 10 in 5 minutes, 10 in a 5 minutes. Then what about in a 60 minute? Then what about in 60 minutes? So this is a simple question. Then 60 divided by 5 into 10. So this is 120. 120 per hour. This is the value of mu. Once if you know the value of lambda and mu, so then you can find the values of, so average number of customers in the system. That formula already we know, that already we have studied. LS equal to LQ plus of lambda divided by mu. What about the second one? Average number of customers in the queue. Average number of customers. So in the previous problem also we solved the same thing. Lambda square divided by mu into mu minus lambda. And third one is average time a customer spends in the system. Average time a customer spends in the system, that is WS is equal to 1 divided by mu minus lambda. 1 minus of mu minus lambda. And last one is the average time a customer waits before served, that is WQ. WQ is equal to lambda divided by mu into mu minus lambda. So these are all the formulas we are supposed to use, and these formulas taken from the those formula set of the formula. Okay, now here, so this is the answer I given. So lambda is equal to 9 customers arrive every 5 minutes. It means that for 60 minutes, how many customers arrive? 9 into 12. So how this 12 is coming? So 5 minutes of, 12 numbers of 5 minutes are available in 60 minutes. So it's left to you. So how will you understand? So better go for the 60 divided by 5. So for this, instead of 12, you can directly take the 60 divided by 5. So that is a good one. And for the mu, 10 customers served in the 5 minutes. So 10 customers served in the 5 minutes, it means that 10 into 60 divided by 5, that is the 120. That is the answer. Next one, average number of the customers in the system, with that formula, and the answer will be 9 customers, because I don't want to put the values and get the answers, because already you are in the last semester, so you can do it yourself. And next one is average number of customers in the queue. So that formula is lambda square divided by mu into mu minus of lambda. So if you put all this, so you will get the answer of 8.1 customers. While writing the numbers, so you need, if it is a time, then you need to write in terms of minutes. If it is a number, then you need to write a customer. Only these two are the units we need to follow in this queuing model. This is the fourth answer. Next, we'll move on to the next different type of problem. It's this problem is little bit different compared to the all the 4 problems. This fifth problem, at an emergency ward of a private hospital, which can handle only one patient at a time. Which can handle only one patient at a time. It means that, again, it is the MM1 model, one patient at a time. It means that they are serving to the single patient. 96 patients arrive in a day on an average. Okay, 96 patients arrive in a day on an average. It takes on an average of 10 minutes to give treatment to a patient. It takes 10 minutes to give a treatment of a patient. Okay, this is 96 in a day. 96 in a day, not in a 1 hour. Not in a 1 hour. The cost of treatment is 200 per patient for 10 minutes. The cost increases at rupees 20. The cost increases at rupees 20 per minute of a time reduced. It means that if you reduce the, instead of taking the 10 minutes, if you serve them for only a 9 minutes, then the the charge will be 220 rupees. That charge will be 220 like that. So the cost increases at rupees 20 per minute of a time reduced. So how much time is reduced from the 10 minutes? So for 1 minute, charge will be 20 rupees extra. How much amount should be budgeted by the clinic to reduce the queue size to 1 by 2? Queue size to 1 by 2. So it means that the question is clear that first we need to find the queue size. First we need to find the queue size. So whatever the queue size will be there, for example 1, so that you need to reduce it to the 1 by 2. That you need to reduce it to the 1 by 2. Then we need to find the what is the budget. What is the budget? Or else what is the amount should be paid by that patient. Okay, in this problem, we need to note the following points with respect to the problem. First one is the problem gives the information on the cost incurred for a normal standard for the 10 minutes treatment, that is 200 rupees. And the second one is this fee is the true for the actual queue length, which has to be calculated from the given mu and lambda. We need to find the lambda and mu. Okay, what is the lambda and mu now? What is the lambda and mu for the given problem? Okay, lambda and mu is the okay. They are told that okay. Yeah, first we'll finish up this information. But if the queue length has to be reduced to 1 by 2, the service rate mu has to be increased, obviously, because so whatever the numbers of customers are coming to the hospital, that patients are coming to the hospital, that we need to serve. If the more customers are coming, then obviously that service rate should be a more. Next, therefore, we have to find the actual queue size. Find out then the increase in mu required to reduce the queue size, and then finally calculate the cost involved in reducing the time. Okay, now a mean arrival is 96 patients per day. 96 patients per day. So per day in the sense, so how many hours are in the one day? So 24 hours. And as it is the hospital, they are given the hospital. So obviously working hours of the hospital will be 24 hours. So it's not a 8 hours or the 10 hours. We need to consider the 24 hours because so this problem is the emergency ward. So we need to consider the 24 hours. So in 24 hours, total 96 patients are coming. It means that how many patients are coming per hour? How many patients are coming per hour? So 96 divided by 24 in a one day. So total 96 customers are coming. So patients are coming. So 96 divided by 4, 24 is 4 per hour. This is the lambda value. And next one, what about the mu value? Mu value is 10 minutes to give a treatment to a patient. So for one person at 10 minutes. So then in 1 hour total he can serve up to six patients. So that is the 6 per hour. These two are the lambda and mu values. Once if you know the lambda and mu values, then we need to find the first we need to find the queue length. After that we need to find the mu value. Again, we need to find the mu value. So what is the new one? So new service timing. Okay, here, okay, lambda and mu already finished. Okay, now we need to go for the finding the queue length. Queue length is the LQ equal to, so this formula we need to use lambda square divided by mu into mu minus of lambda. So then we got the value of 1.33 patients. So length of the queue is the 1.33 patients. Okay, here, if LQ is 0.5, in the question they are given that if it is reduced to 1 by 2, so 0.5, then what is the mu new? What is the new service rate that we need to find? Now we know the value of 1.33, but if you reduce it to 0.5, then what is the mu new? Okay, again use the same formula. LQ is equal to, instead of using the old mu, we need to find the new service rate here. We know that LQ is they are asked for the 0.5 and the lambda square also we know, and so we can find the value of mu nu. So by using the that x equal to minus b plus or minus square root of, or also even you can go for the any, so directly by the calculation also you can calculator also you can use the x square minus of 4x minus of 32 equal to 0. This is the equation. So here the x equal to mu nu. Okay, by using that quadratic equation, we can get the value of mu nu. So that is 8 per hour. So it means that earlier the service rate was 6 per hour. So now if you reduce the queue length, then the service rate will be up to 8 per hour. So it means that he is serving the more number of customers. If he is serving 8 customers in a 1 hour, so then what is the service rate now? What is the timing? How much timing he is taking? So service time for each patient is 60 divided by 8. That is 7.5 minutes. 7.5 minutes. Therefore, when service time is 10 minutes and the service rate will be 6 per hour. So this is as per the given data. And for the new one, so when it becomes the 8 per hour, it becomes 7.5 minutes. This means that the time taken to treat a patient or an average has to be reduced from 10 minutes to 7.5 minutes, getting a reduction of 2.5 minutes. So in the problem statement, they are given that if there is a reduction in the time for 1 minute, they have to pay 20 rupees extra. So there is a total 2.5 minutes is extra. So then they have to pay 2.5 into 20, that is 50 rupees they have to pay extra. So earlier it was a 200. So now it should be 250 rupees. So budget required to keep queue length to 1 by 2 is a rupees 250. This is the way we need to solve the problem. And another there are, so this is a one more problem. You can take it as a homework. You can take the screenshot, and there's a one more. So even this problem is also quite interesting, because one value is given per hour and the another value is given in terms of minutes. Thank you. Any doubts you can ask me. Okay, you can put it in a chat box. If you have any doubts, you can put it in a chat box.